What's the standard error of a hypergeometric? Random variable. It's kind of like the binomial, except for the finite population correction because you're drawing without replacement, right? Okay, if this were just a binomial, sorry? You'd be, was that a question? No, that was a stretch. Okay. If this were a binomial, it would just be the square root of the number of draws times the SD of the box, right? What's the SD of the box? Okay, so we've got a 0, 1 box. We have a fraction p equals g over n equals 7 over 18 of tickets labeled 1. Right? SD of the box is the square root of p times 1 minus p, which is the square root of 7/18 times 11/18. Right? This is the SD of a 0, 1 box. If it has a fraction, any 0, 1 box, if it has a fraction, it's the box, right? We've got a box of tickets, and it has a fraction p. So there's n tickets in the box in all, right? A fraction p of them are labeled 1. A fraction 1 minus p of them are labeled 0. Right, so we're talking about the box. What is the SD of that box? SD of that box is square root of p times 1 minus p. Okay? Now, what are we doing with that box? What we're doing with the box is different in different random variables, right? Okay, what we're doing with the box in this case is drawing 5 tickets without replacement at random. Okay, so for that, how is the standard error of the random variable related to the standard deviation of the box? Well, it's related through the finite population correction times the square root of n times the SD of the box. Okay? If we were drawing with replacement from the box, little n times, and counting how many tickets labeled 1 we got, then we wouldn't have f. Right? The standard error of a binomial is just the square root of n times the SD of the box. Square root of n times the square root of p times 1 minus p. Right? But the SD of the box itself. Now, if we didn't remember that this was the SD of a 0, 1 box. Sorry?
Was there an equation with the square root in the denominator?
For the sample mean.
Okay.
Yeah. We're talking about sums here. Remember the standard error of a sum tends to grow as the number of terms in the sum grows, right? It grows like the square root of n. The standard error of a mean tends to decrease as the number of draws grows. It decreases like the square root of n. This is the square root law. Okay, so we're talking about the sum, how many tickets we get labeled 1, not the fraction of tickets labeled 1 that we get in n draws. Right? So that standard error is going to tend to get bigger, except for the issue of f, which is going to eventually, right? If we took capital N tickets out of the box, f would be 0, and so the standard error would be 0. There's a trade-off. Okay, do people remember where this comes from? Nope. Do you care? Yep. Okay. I'll show you then. Okay, we've got this list of numbers. It looks like 1, 1, 1, 1, 1, 0, 0, 0, 0, 0. There are n times p ones. There are n times 1 minus p zeros, right? Okay, so the question is, what's the standard deviation of that list of numbers, right? That's the SD of the box. Huh? So how do we find the SD? Well, first we find the mean. Then we look at the sum of the squared deviations from the mean. We average that, and we take the square root of the result. right? It's the root mean squared deviation from the mean. Back when we were finding SDs of lists once upon a time. Okay, so what's the mean of this list? Well, I get, if I added all these numbers together, what am I going to get? There's n numbers in all. I get a 1 for each one. I get a 0 for each 0, right? If I add all these together, the sum is going to be n times p, right? It's going to be how many ones there were. Now, that's the sum. What's the average? Right? Sum divided by how many there were. So the average of a 0, 1 box is the fraction of ones in the box, p. So now I want to make the list of squared deviations from the mean so that I can take the sum of the squared deviations from the mean and divide that by n to get the mean of the squared deviations from the mean, the average. Okay. And then take the square root of that. All right, so each one, what is that? What's the deviation of a ticket labeled 1 from the mean? Well, it's 1. The mean is p, right? And I want to square that deviation. So this 1 gives me a term 1 minus p squared. This one gives me another term 1 minus p squared. This one, right, et cetera. And then what do the zeros give me? There's going to be n times p of these. These are going to give me 0 minus p squared plus 0 minus p squared plus et cetera. And there's going to be n times 1 minus p of those, right? So what is the sum of the squares of the deviations from the mean? Well, it's 1 minus p squared, sorry, it's 1 minus p squared times that, there's that many of them, plus 0 minus p squared times that. There's that many of those. Let's go put this over here. All right, so I've got n times p times 1 minus p squared plus n times 1 minus p times 0 minus p squared is just p squared. Right? This is 0 minus p squared in some illegible handwriting. Right? And what am I going to do with these? I want to take the average of the squares. So I'm going to divide this by n to get the mean of the square deviations. That conveniently cancels that. Yes? And now, if we look at what's going on here, both terms have a factor of p, and both terms have a factor of 1 minus p. This one has an extra factor of 1 minus p. This one has an extra factor of p. So I can write this as p times 1 minus p times 1 minus p plus p. Everybody see that? P times 1 minus p times 1 minus p is p times 1 minus p squared. P times 1 minus p times p is 1 minus p times p squared. Same thing? Okay. What's 1 minus p plus p? Okay, so this is p times 1 minus p. And now what's the last step in finding the standard deviation? Take the square root of it. Okay, so the standard deviation of a 0, 1 box is the square root of p times 1 minus p. Right? That's where that came from once upon a time. Okay, so we're back to finding the standard error of x. And we're drawing without replacement, so that introduces the finite population correction f. F is the square root of n minus n over n minus 1. And the standard error of this random variable is going to be f times square root of n times the square root of p times 1 minus p. What's p in this case? It's g over n, right? The fraction of tickets labeled 1 in the box. There's g in all. There's g labeled 1. There's n in all. And then times 1 minus g over n. Okay? So plugging into this would give the answer.